trig functions. Okay, everybody, we're going to continue on with our inverse trig functions. The first couple will look very similar to what we did in the last lesson. I'm looking for the inverse sign of the sine of pi over 6. It may help you, one, to remember where we are allowed to evaluate our inverse functions. You can take the sine, cosine, tangent of any angle. So we're just going to start there. I'm going to say, what is the sine of pi over 6? And we would say that would be 1/2. Then I say to myself, okay, what is the inverse of 1/2? What angle is that going to get me? Again, sine can be evaluated in quadrants 1 and 4. It's positive, so we must be in quadrant number 1. And we're going to get pi over 6. We learned in the last lesson that the inverse of the sine, so long as you're in a area where it's all defined, you can just cancel each other out. If I'm looking for the cosine of 3 pi over 4, that would put us in quadrant number 2. Cosine is valid. The domain is restricted in quadrant 2 there. These would cancel each other out to get 3 pi over 4, or we could go through the process of evaluating. The cosine here at 3 pi over 4 would be negative square root of 2 over 2. Then when I take the inverse of that, that would bring me right back to 3 pi over 4. When I'm looking at the tangent of 0, so 0 pi, so this is an angle, I want to say what is the tangent at this point. That is the point 1, 0. Remember that tangent is y over x. So we're going to say, okay, what is the inverse where now the 0 is acting as a coordinate? And then again, we would go back to saying that would be at 0 pi. You do not need to write the pi symbol after that. I like to do it, so it just keeps me on track that I'm actually listing an angle and not a coordinate. If I'm looking at the sine of 5 pi over 6, there's a couple of approaches to this one. One, I can just go ahead and evaluate. I'm over here at 5 pi over 6. The sine there would be 1/2. We're in quadrant 2. Y is positive in quadrant 2. But when I go back to evaluate the inverse sine function, I can only pick an angle up either in quadrants 1 or quadrants 4. Since it's positive, it must be coming from quadrant 1. And we would evaluate this to be pi over 6. Another approach, looking at the way we did yesterday, saying what is the reference angle for 5 pi over 6. Put that in a valid spot where we can evaluate the inverse, and you can look at the problem that way as well. All right, let's scooch down a little bit. I'm not getting very far. There we go. All right, so we're looking to evaluate the inverse cosine of the cosine of 7 pi over 2. Remember, you can evaluate an angle anywhere on the unit circle. 7 pi over 2 would put us right here. The coordinate there is 0, negative 1. Cosine is, of course, the x value, so now I'm looking for the inverse cosine of 0. Now I need to evaluate this somewhere where cosine is valid, which is either in quadrants anywhere from 1 and 4. So we're going to move ourselves up to this point up here. So we would say the inverse would therefore be pi over 2. For this tangent problem here, 4 pi over 3 would put us over in this quadrant here. The coordinates would be, negative 1/2, negative square root of 3 over 2. If I'm looking to find the tangent, it is y over x. The 2's would cancel out, and where we're going to get ourselves is to find the inverse tangent of positive square root of 3. Again, tangent we must evaluate either in quadrants 1 or 4. That's where the domain has been restricted. And since it's positive, we're going to bring ourselves up to quadrant number 1, and that would bring us to pi over 3. These are starting to look a little different. We're putting different trig functions together. Again, it's just a process we're going to go through. Evaluate the angle and then take the inverse on the outside. Just like any composite, we start on the inside and move to the outside. So first I'm looking at here, pi over 4. What is the cosine of pi over 4? And we would say that is the square root of 2 over 2. Now I need to evaluate the inverse sine. Sine is restricted to quadrants 1 and 4. We are in 1. It does happen to have the same coordinate as cosine, so we are going to come up with pi over 4. 7 pi over 6. The sine of 7 pi over 6 puts it down here in quadrant number 3. For the inverse sine is not valid in 3, but we can just evaluate any angle. Sine will be negative because it's the y value. So I'm looking at the inverse cosine of negative 1/2. Now that I need to evaluate cosine, cosine has been restricted up to quadrants 1 and 2. Since it's negative, we are looking for an angle that will be sitting in quadrant number 2, and the angle that produces that coordinate is 2 pi over 3. Okay, moving on to the next section here. I want to find the exact value of an expression involving some trig functions. Looking in here, this is a little bit different. We have the inverse trig functions that are sitting inside the parentheses here. So we do have to make sure we're evaluating where those are valid. Tangent on our normal unit circle will never equal 1/2. So we have to kind of think to ourselves, where is tangent valid? So we're going to say either in quadrants 1 or 4. Since it's negative, we're going to be sitting in quadrant 4. The terminal side will be sitting there. Tangent is y over x. We're going to have, I made a mistake there. That is not negative. So we're going to be sitting in quadrant number 1. My apologies, folks. So I know tangent is y over x. Y is your vertical. X is your horizontal. We need to figure out what this terminal side is. We'd be using the Pythagorean theorem. So c squared is going to equal 2 squared plus 1 squared. And that's where we get the square root of 5. So I'm looking to evaluate the tangent of 1/2. It is some angle theta. We do not know what theta is. So I'm just going to say, okay, I now need the cosine of theta. I go back to my triangle. I look at angle theta. Cosine would be x over r, or the adjacent over the hypotenuse, however you want to think about that. So we are going to be getting 2 over the square root of 5. Of course, we need to rationalize, leaving us with 2 square roots of 5 over 5. Alright, so same thing here. I'm looking at the sine of negative 1/4. That is not something that's on our general unit circle. So we're going to have to figure out what we have here. Since sine is negative and it can only be valid in quadrants 1 and 4, we are going to be sitting our triangle in quadrant 4. This is going to be for some angle theta. Sine is y over r, so this is going to be negative 1. The 4 would go on to the hypotenuse. Again, using Pythagorean theorem, we would get this to be the square root of 15. So I'm evaluating the inverse sine. I'm just going to say that is representing some angle theta, even though I don't know what theta is. But we have our picture over here to help us. We're now going to take the cosine of that. And again, cosine is the adjacent over the hypotenuse. So we're going to evaluate this as the square root of 15 over 4. Working this problem again, looking at the cosine here, 2 over 3 is not a common value for cosine, so I know I'm off the unit circle. Cosine is valid in quadrants 1 and 2. Since it's negative, I know our triangle is going to have to be in quadrant number 2. Cosine is x over r, or the adjacent over the hypotenuse. Remember that the negative is going to go on the coordinate side, that radius or the terminal side will always be positive. Using Pythagorean theorem, we get the square root of 5. Since I'm in quadrant 2, that vertical will be positive. Again, we're naming this some angle theta. So when I take the cosine, the inverse is to get me an angle. The angle I am getting is theta, even though we don't know what theta is, but we have our picture to reference. I then want to find tangent. Tangent is y over x, so we're going to wind up with negative square root of 5 over 2. All right, flip your papers over. We'll go to the back page. We're going to talk about our secants, our cosecants, and our cotangents. For secant and cosecant, they are defined exactly where cosine is for secant and where sine is for cosecant. Remember, they're family members. I've said before, at least in my classes, the cotangent's kind of like the black sheep of the family. So he's going to be valid in a different spot that tangent is. Well, tangent is valid in quadrants 1 and 4. For cotangent, it's going to be between 0 pi and between 0 and pi. The way I work these problems is I just kind of switch back to the ones that I'm more familiar with. So I'm going to be looking at saying, okay, if the secant here is square root of 2, then the cosine would be 1 over the square root of 2, which if I rationalize that would become square root of 2 over 2. So I'm looking for the inverse of that. Cosine is valid in quadrants 1 and 2. Since it's positive, I am looking for an angle in quadrant number 1. And we would pull the angle of pi over 4. Again, secant is part of the cosine family, so this would be the inverse. Of course, it's just a flip of negative 3 over 2 square roots of 3. Once I try to rationalize that, I would get negative 3 square roots of 3 over 6, which would then reduce to be, let's see here, negative square root of 3 over 2. That is an angle that should seem familiar to us on our unit circle. We're talking about cosine. Cosine, again, valid in quadrants 1 and 2. Since it's negative, we are going to be in quadrant 2. And what angle would produce negative square root of 3 over 2? That would be the angle 5 pi over 6. Our next problem here, problem C, we're looking at a cosecant. That is the sine family. So the reciprocal of this would be 1/2. Sine is valid in quadrants number 1 and 4. It's positive, so we're definitely looking to pull an angle out of quadrant 1. Where is sine 1/2? And that would be pi over 6. All right, just 3 examples to go, and then you guys can start your practice. Cosecant, again, is part of the sine family. When I take the reciprocal of this, we wind up with negative 3 over 2 square roots of 3. Once rationalized, we wind up with negative square root of 3 over 2. I'm looking to, for the sine family. Sine and cosecant are valid in the same areas. We're looking at either quadrants number 1 or 4. Since it's negative, we have to be in quadrant 4. What angle would give us this coordinate? That would be negative pi over 3. Remember that sine has been defined in the domain of negative pi over 2 to pi over 2. So we cannot name this as 5 pi over 3. We do have to name it in a domain where that is valid. Again, for cotangent, you just need to remember that we're actually in quadrants 1 and 2 for this one. It is different from the tangent. So if I was to flip this around, the tangent would be 1 over 0. I want to know what angle is going to get me that. I'm going to have to be somewhere in between quadrants 1 and 2, and that would get me pi over 2. When we're here, we're at the coordinate 0, 1. So for cotangent, it would be x over r, which would get us 0. If you're looking at the tangent, you get that undefined status there. Where is cotangent negative 1? Again, being defined into quadrants 1 and 4, we're going to have to be in quadrant number 2. Since cotangent is x over y, we are looking at 3 pi over 4, because the coordinates there, a negative square root of 2 over 2, square root of 2 over 2. Once you put x over r, we do get a negative 1. All right, that's it for today's lesson. I will pick up with you the next time.